Hello everyone, my name is Chris Hickson. I'm a student teacher at Miles ELC in the middle school math classroom. This is the lesson I presented January 12th, 2017 for 4th and 6th period. For this lesson we reviewed proportional rates. Our agenda for the day was to work on our bell work, take a look at the monthly schedule, the monthly outlook, review the homework that we had done, or they were supposed to have done the previous night, do a mind break and a raffle for 4th period. And a raffle is just an opportunity for them to win homework passes or small amounts of extra credit or clan points. And after that we were getting into class notes, and then at the end of the class we took a MEOW quiz. And MEOW stands for Math End of Week Quiz. So at the end of each week we have a small assessment to determine whether or not the students have understood the week's lessons. Their objective was to show mastery of proportional rates through their MEOW quiz. So as you can see in our bell work, both questions are tables, and the question is to find out whether those tables are proportional. In order to do this, we need to find the unit rate for each pair of coordinates, each x and y column in this case. So if we recall from our previous lessons, if we take y and divide by x, we will find the unit rate. And this is going to be important because in order to determine if our table is proportionate, we must first determine if the table has a constant of proportionality, or if it has a constant rate of change. In order to do this, we must take each of these coordinates and determine their own rate of change. Excuse me. So for the first one, we're going to divide 5 by 1 because we're dividing the y value by the x value in order to determine the rate of change. Excuse me, I'm sorry. So 5 divided by 1, remember it's our y value, which in this case is 5, divided by our x value, which is 1. 5 divided by 1 is 5. So our rate of change for the coordinate 1, 5 is 5. Now if we take a look at our second pair, 15 and 3, we have to determine the unit rate there. So our y value is 15 and our x value is 3. So once again we'll set up our ratio 15 to 3, and now we have to divide. 15 divided by 3 is once again 5. So the rate of change here is 5. Now we'll take our third pair. Our y value is 25 and our x value is 5. So again, we'll set up the ratio in order to determine the rate of change. 25 divided by 5 is 5. Now you'll notice each of our rates of change are 5. Because the rates of change do not fluctuate, they don't go up or down, they're all the same number, they're all 5, then we can determine that this table does have a constant rate of change. It's going to be constantly changing by 5. If we look back in our previous lesson, the definition of a proportional table required having a constant rate of change, and this has that constant rate of change, therefore it is proportional. Now, for the second one, we're doing pretty much the same thing. We've got a very similar table, and we are going to determine different rates of change. That way we can verify whether or not we have a constant rate of change. So if we just take our old table, we already have set up the ratios and divided for both the first and second points. So the rate of change for our first set is going to be 5, as well as our second set. We have not, however, done the third set there. So we'll need to set up our ratio once again and find our rate of change. So recall that it is y divided by x. So 20 is our y value, and 4 is our x value. So 20 divided by 4 is also 5. Once again, you'll notice that each of our rates of change are 5. Therefore, we can determine, because each of our rates of change are the same, we can determine that it is a constant rate change. And because it has a constant rate of change, the table is in fact proportional. Again, just to clarify, in order for a table to be proportional, it must have a constant rate of change, and we have verified that this does have a constant rate of change. And that's the end of our belt work. This is our monthly outlook. If you have watched the previous videos, you'll know that this is the same. We're going over proportional rates. We're off Monday the 16th. Then we'll be going into proportions again, but this time we'll be talking about the butterfly method. Now I'll write an example of this in case you've seen this. I'm not going to go into detail as to what that means exactly, but that's what we'll start working on Tuesday the 17th. Well, I'd like to point out that each Thursday we have a meow quiz. So again, these are just brief, short assessments to determine what the students have learned that week, what they've retained. Monday the 23rd we have an exam. This exam that is coming up is going to cover the proportional review that we've done this week, as well as the proportions work we'll be doing with the butterfly method the week of the 16th. After the exam, we'll be getting into decimals. First, we'll be adding and subtracting decimals, and by Thursday, we'll be multiplying and dividing decimals. Once we've gone through decimals, we'll start talking about percent quantity. I'll write up a brief example of this as well. So again, I'm not going to go in great detail at this point, but essentially what we'll be having the kids do is if given a number, they'll be able to determine different percentages of that number. Percent of quantity is an important skill for the students to learn because this will lead them into tax, tip, and discount. So the next thing we did is our homework review. So I'm not going to go over that because that's essentially the work that we had done in the last class. Then we took a mind break. Mind break is an opportunity for students to stretch and to take a break in order to refocus. The next thing we did in fourth period was do a raffle, and then we got into our class notes. So in our first example, Frankie made a graph to show how much money she saves after each week. Use the proportional graph below to answer the following questions. What is the unit rate of the graph? I believe the UDE units was supposed to be include the units, but that got cut off, so we don't have to really worry about that. So remember, in order to determine the unit rate, we must find the rate of change or the ratio of change. So we'll need to set that up as y over x. So recall that on a graph we have two axes. We have the vertical axis going up and down, that's the y, and the horizontal axis going left to right, which is the x-axis. Now notice the second point on the graph, or the third point on the graph. If you count, it's two numbers over on the x and 2 up on the y. So it should be 2, 20. I wrote 10, 20, and I'm not going to catch it until I'm done with the math here, but I will catch it. So just ignore this part of it, and once I've caught my mistake, I will come back and we will continue to explain this. But again, the numbers in parentheses, the point should be 2, 20, not 10, 20. I've still not caught my mistake, but I will in just a couple of seconds. I believe it is at this point. Yep, this is the point where I recognize that I had made a mistake. So we're going to jump all the way back. Thank you for bearing with me. So we've got y over x. So we need to set up the savings amount divided by the number of weeks. So if we take our point, the point is in fact 2, 20. So when we set that up, 20 is our y value and 2 is our x value. Now this is our ratio, but it is not, and it is a rate of change, but it's not the unit rate of change. We need to reduce this fraction. So in order to do that, we need to divide both the numerator and the denominator by 2. 2 divided by 2 is 1, so our new denominator is 1, and 20 divided by 2 is 10, so our new numerator is 10. Now this is our unit rate. This is our unit rate of change. And because the graph is proportional, it's also assumed that this is our constant rate of change. Now it's important here to include the units because 10 over 1 doesn't really say anything to us. So because our y value is in dollars, as you can see, is marked by savings, and the bottom is labeled as number of weeks, we have $10 per week. Now the second question is, what is the equation of the graph? Now, we're going to need the unit rate, or the constant rate of change, in order to determine our equation. Excuse me. Now, the constant rate of change tells us that we are constantly increasing, the y value is constantly increasing by 10. So, no matter what value we have for x, we can multiply that by 10, and that will give us the corresponding y value. So we can write this as y equals 10x, or y equals 10 times x. For C, it says, how much money can Frankie save after 4 weeks? How do you know? So there are a couple of ways to do this. You could go to the place where it says 4 weeks. So notice at the bottom, the x-axis, it's labeled as weeks. So you could go to the 4th week and then find the corresponding dot on the graph, on the line. Or you can substitute and use our equation. The information they give us is 4 weeks. Weeks is the label for the x value. Therefore, 4 must be substituted in for x. So instead of writing x here, we're going to write 4. So now our equation is y equals 10 times 4. 10 times 4 is 40. So y equals 40. And y is the number of dollars saved, as you can tell by our graph and what it's labeled. What this is saying is that over 4 weeks, Frankie will have saved $40. D says, what does the point 2, 20 mean in terms of the context? So we've got the point 2, 20, and you can see that that's located on the graph as the 3rd point. If we go to 2 as our number of weeks on the x-axis and go up to the line, it is located with a corresponding y value of 20, which we can tell from our label on our y-axis is the number of dollars saved. So we can determine that 2, 20 in context means that Frankie has saved $20 over 2 weeks. Example number 2. Harry created a graph to show how far he can run in miles after a certain amount of track practices at school. Use the proportional graph below to answer the following questions. So we could take time to determine the proportionality of this graph, and we did during class. However, because it is stated in the question or in the information there that it is proportional, we're not going to do that now. And it is not necessary to do it. A says, write an equation using the unit rate. In order to use the unit rate, we must first determine the unit rate. So, if you'll notice, we don't have any points here, so we're going to need to find our points. But it looks like, or in order to find the rate, we need to have the y value divided by the x value. So if you go to 10 on our x axis and go up to the line, you'll see that the corresponding y value is 30. So our point is 10, 30. Now we'll need to take this information and plug it into our change of rate formula, y divided by x. Since the y value is 30, it will go on top, and we'll have 30 divided by 10. So now we've got our rate of change, but we need a unit rate. In order to get a unit rate, the denominator must be 1, therefore we must divide both the top and bottom by 10. This will give us 3 over 1. Now we've found the unit rate. Now we're going to take this unit rate and set it up as an equation. So remember that our unit rate, our constant of proportionality, our constant rate of change, says that for any x value we have, we can multiply by a constant rate of change in order to get our corresponding y value. Since we found our constant rate of change to be 3, or 3 over 1, we have determined that for any x value, we can multiply it by 3 and it will give us the corresponding y value. For example, on the graph you can see if we plugged in 10 for x and multiplied by 3, we would get the corresponding y value of 30, which matches what our line is on the graph. If we plugged in 20 for x, we would get the corresponding value of 60, which matches what we have on the graph. This would continue to work for as many x values as we care to plug in. The next question says, use the equation to find how many miles Harry runs in 40 practices. So I'll write our equation up here, y equals 3x, or 3 over 1x. So, first we have to determine what we will be substituting in for 40. 40 practices, as we saw, is located on the x-axis. Practices is the x label. Therefore, we'll substitute the 40 in for x. So instead of y equals 3x, we'll write y equals 3 times 40. 3 times 40 is 120. So our answer will be 120 miles. It's miles because if you recall, our x-axis is labeled as distance or miles. Therefore, our answer, y equals, must be some number of miles. In this case, 120 miles. So what this is telling us is if Frankie attends 40 practices, he will have run a total of 120 miles. C says, use the equation to find how many practices it will take to run 210 miles. So before, the question offered us 40 practices, but now it's talking about miles. So we need to determine which variable we're going to substitute in 210. So practices is not what they're talking about in this question. They're offering us 210 miles. Because miles is located on our y-axis, we want to then substitute the y with 210. So instead of y equals 3x, we'll write 210 equals 3x. In order to figure out what x is, we have to get rid of the 3. Right now, 3x means we're multiplying 3 times x. In order to undo that multiplication, we must divide by 3. But if we divide by 3 on one side, we must also divide 210 by 3. 3 divided by 3 is 1. But we'll just write that as x. Now what we've got left is 210 divided by 3. So we'll see what that is. Three does not go into 2. 3 does go into 21. Seven times. I apologize for the short break. I was being texted by my wife. Anyway, 7 times 3 is 21. 21 minus 21 is 0. And we've got the 0 left to move up top. So 210 divided by 3 is 70. X equals 70. So what does this tell us? Well, if you look on our axes, our x-axis is labeled as practices, so 70 must mean practices. So we know practices and miles. So from the information we have, we can determine that if Frankie runs 70 practices, he will have run a total distance of 210 miles. So that's the end of our lesson. After this, the students took a meow quiz. Again, that's just an end of the week assessment to see what they've retained from the week. And so that's pretty much it for this lesson. Thank you again. If you have any questions, please leave a comment, or you can come to me directly or email me. Any way you'd like to leave feedback is appreciated. Thank you very much, and I'll see you guys next time.